Welcome to part 2 of absolute value functions. Here we are going to solve equations that have absolute value in them. So we're first going to write down these equality properties. This is the mathematical notation. We will then explain it using some numbers. The first property is pretty straightforward. It says if the absolute value of x is 0, that's if and only if x equals 0. This IFF means if and only if. So the only way that the absolute value of x is 0 is that if x is 0. And we know that. The only way this could equal 0 is if what was inside is 0. The second one's a little more complex. It splits up if the absolute value of x is anything other than 0, basically if it's c. Then we have two options. Either c is a positive number or c is a negative number. And if c is positive, then either what's inside here, x, was c, or negative x equals c. Now the way that we can look at this is that we can look at this as x equals c or x equals negative c if we were to divide both sides by -1. So we'll write aka x equals negative c. That is just an alternate way of writing negative x equals c. We can also write it like this. So if c is less than 0, so if the absolute value of x is a negative number, then there is no solution because the absolute value by definition is a number's distance from 0, and the absolute value of x could never equal a negative number. Let's explore this down here with some real life numbers. Let's say that we have the absolute value of x equals some value c, and I'll make that c value 3. So we have this scenario here. Which one do we have, 1 or 2? Well, we have this one because 3 is greater than 0. So we have to think about what are the possibilities that x could be. What number inside the absolute value could be in here such that it would output as a 3? Well, x could equal 3. It could equal what c was. So one example is, so if we had this, one answer is that x could just be 3. If we plugged 3 back in, we'd have the absolute value of 3 is 3. Or we have that x could equal -3. Let's see if that works. If we plugged in -3 for x, is the absolute value of -3 equal to 3? Yes. So this situation, if we have the absolute value of some number is 3, then that number could have originally been 3 or -3. Let's take a look at the second scenario down here. What if that number was originally negative? If the absolute value of x equaled originally -3, then we have no solution. And that's because the absolute value of something can never equal a negative number. An absolute value, by definition, is a number's distance from 0, and an absolute value on its own can never equal a negative number. So basically, this is what our equality properties boil down to. If we have the absolute value of x equals c, and as long as c is a positive number, then either x originally was c, or x was the opposite, or negative c. So this is the main thing that you should take away from those three properties. We're going to use this idea to solve absolute value equations. Let's take a look at the first one. Here we have the absolute value of something, and it equals a positive number. By our equality property, what we have is what was on the inside either equals +6, or what was on the inside could equal -6. If we think about that, that makes sense. What was on the inside here could have been 6, because its absolute value would definitely be 6. What was on the inside here could have also equaled -6, because when we take the absolute value of -6, it still gives us 6. So once our absolute value is isolated, it's all alone, which this was, we set what was inside to +6, and we also set it equal to -6 because we have two possibilities. Then we solve. So we'll solve this side first. We'll get 3x equals 7 and divide both sides by 3 to get 7/3 is one possibility. Or on this side, we'll solve, get 3x equals -5, divide both sides by 3, and we'll get that x could have been 7/3 or -5/3. In our second example here, we do not have the absolute value isolated yet, so we need to do some prerequisite work first. We need to get the absolute value part by itself. So we'll first start by subtracting 3 from both sides. Then we have negative times the absolute value of x plus 5 equals negative 2. We still have this negative out front, so we'll divide both sides by negative 1 to get rid of it, so we can get the absolute value by itself. So we have the absolute value of x plus 5 equals 2. Again, we have the situation where the absolute value equals a positive number. By that equality property, what was inside the absolute value could have equaled 2, or what was inside the absolute value could equal negative 2. We have to account for both scenarios. Solving, we get that x could equal negative 3, or solving this side, we get that x could equal negative 7. If you were to plug either negative 3 or negative 7 back into your original equation, you would have something that is true. This one looks a little more complex because it has a quadratic involved, but we do have the absolute value isolated, so we can go ahead into our two scenarios. What was inside the absolute value could equal the positive version of the right-hand side, or what was inside our absolute value could equal the negative version of what was on the inside. Notice here I'm putting parentheses. That's because when I make something negative and it's more than one term, I need to end up distributing that negative through. So I'm still doing the exact same thing I've been doing on all these problems. So what I'm going to do is distribute that negative through. So we'll have negative x squared plus 6. Now for solving this, let's take a look at this side and let's solve. When we have a quadratic, we want to keep the quadratic term positive and set it to 0. So I'm going to subtract x on both sides. So we have 0 on this side. We'll have x squared minus x minus 6. Now solving a quadratic, we need to see if it's factorable. Are there two numbers that multiply to negative 6 that add to negative 1? Yes. Those numbers are negative 3 and positive 2. When we're solving a quadratic, we set each factor to 0. So we'll set x minus 3 equals 0 and x plus 2 equals 0. Adding 3, we'll get the possibility of 3 and negative 2. So these are two possibilities so far for x. On the right-hand side, we want to keep the squared term positive and get it to 0. So I'm going to add x squared and subtract 6. And we'll do that to both sides. So on this side, we'll have x squared plus x minus 6 equals 0. Again, it's a quadratic. We want to see if it's factorable. Are there two numbers that multiply to negative 6 that add to positive 1 in here? Yes. Those numbers are positive 3 and negative 2. We set each one of those factors to 0 to solve. And here we'll subtract 3, so we'll get that x could be negative 3. Here we'll add 2, so x could be 2. Now, I say that x could be these values. I'm going to box them. We need to make sure that they work. So let's check them. We'll do that in white up here. I'm first going to check 3 and see if it works. So if I have the absolute value of 3, I'm plugging it in for x. Does this work? Is 3 equal to 9 minus 6? Yes, 3 works. So 3 is good. Next, let's check negative 2 and see if that works. So if we're checking negative 2, I'll plug in negative 2 for x. So the absolute value would be 2. Here we'll get 4 minus 6. Does 2 equal negative 2? It does not, so that one doesn't work. Next, let's check negative 3. When we plug in negative 3 for x to our original equation, we'll see that this one does end up working again. It's the same as plugging in positive 3 actually, because the absolute value here is 3, and we'll also get 9 minus 6, so 3 does equal 3. So negative 3 works. Lastly, let's check 2. When we check if x can be 2, we'll plug in 2 everywhere there's an x, and we'll see that this one won't work because we'll end up getting 2 equals 4 minus 6, and 2 does not equal negative 2. So our final answers are 3 and negative 3. I checked this one because it is a quadratic and it's just a little bit different. All right, this next example, we want to first isolate the absolute value, so we'll subtract 4. We'll have negative 5 times the absolute value of x plus 2 equals doesn't equal negative, equals 1, 5 minus 4. All right, then we'll divide both sides by that negative 5 that's out front. Well, the absolute value of x plus 2 equals negative 1/5. Now, can an absolute value ever equal a negative number? No. By definition and our initial equality properties, the absolute value has to either equal 0 or a positive number. Therefore, because the absolute value cannot equal a negative number, this has no solution. By definition, an absolute value is a number's distance from 0, which has to be either 0 or a positive number. Because the absolute value equals a negative number, we cannot proceed any further. There is no solution. In our last example, we want to first, again, isolate the absolute value. That's our first step. And then from here, we're going to use our equality property. We're going to say what's inside the absolute value either equals what's originally outside, or what's inside the absolute value equals negative what's over there. So solving on this side, I'm going to subtract x from both sides. Now when we do that, we'll see that the x's end up canceling on both sides, and we're just given a false statement, so this provides us with no solution. Let's take a look at the right-hand side. I'll distribute the negative through. We'll have negative x plus 1. I'll add x to both sides, and then we'll add 2 to both sides to solve. So we're left with 2x on this side equals 3. Dividing both sides by 2 will give us x equals 3/2. Because that one was kind of weird, I'm going to double check that 3/2 works. So I'm going to plug in 3/2 in for x. And 3/2 minus 2, this is like 1.5, right? Minus 2 is like negative half. So we have the absolute value of negative half plus 1, and we want to see if that equals 3/2. The absolute value of negative 1/2 is 1/2. Does 1/2 plus 1 whole equal 3/2? Yes, it does. This is like 2/2, so 1/2 plus 2/2 is in fact 3/2. If you think of it more in a decimal equivalent, right, this is like 0.5 plus 1, it equals 1.5. So this does work. So this is our final answer. All right, I know we went through a lot of examples, and if you are a good note taker, I really recommend that you kind of write down the steps that I say. Won't always write them out, but in order to solve an absolute value equation, here's what we did in every single example. We first had to make sure that we isolated the absolute value. Get the absolute value by itself on one side of the equal sign. Once you have that absolute value all by itself, it's equal to a number, c. Is that number positive? If so, you want to solve by letting what's inside the absolute value equal c, or let what's inside the absolute value equal the opposite of c. We had a potential of 2 solutions every time. If what's outside here c, if that's negative, then we have no solution. So those are the steps for solving an absolute value equation.